This particular video is for science students. Now if you're a science student, you must watch this video to the very end because it explains physics very well. Now all of you should know that this is one of the equations of motion. S is equal to ut plus half at squared. Now so many of you do not know that these particular equations of motion goes beyond what you think. Now I'm going to explain it in a simplified manner. Make sure you watch this video to the very end and do not forget to subscribe to this channel. Now let's start. So the first one, S is equals to ut. Now this one, you see these two things, the reason why we have ut and plus half at squared, because this is what we call a partial variation. And you know, in a partial variation, is a variation that it is partly constant. Now let's differentiate between the two of them. Now the first one, S is equal to ut. This one has to do with velocity. Now whenever you are asked to use this, that means you must be given what? The initial velocity. Imagine they say you should find the speed, distance of a particular, or the distance traveled by a particular car. But you are given velocity. So whenever you are given velocity, or you are asked to use the velocity which is stated, make sure you apply this particular formula. Now in this case, distance is equals to speed times time. This is the perfect formula for distance. But in other way, if you are asked to use, or if you are asked to find the speed of a particular, the distance of a particular vehicle, or the distance traveled by a particular vehicle, but you are not given velocity, but you are still given the time taken, as well as the acceleration, because acceleration has to do with velocity with respect to time. So in this case, not that the velocity is not there, but the velocity varies alongside with time. The velocity of this particular one that I'm about to mention varies alongside with time. So in that case, you're going to use S is equals to half at squared. Now the difference between these two is this one has to do with velocity, and it must be the initial velocity. So the velocity that a particular vehicle starts with, that is the initial velocity. So whenever you are given the initial velocity, apply this formula. Do not worry or do not mind to apply the other one. So whenever you are given this and you are given the initial velocity and you are not given acceleration, just kindly apply distance is equals to speed times time, or velocity times time. So, but in this other case, we can part it the other way. Let's say the car is already moving and you are not given the velocity. So you just apply this other formula, half at squared. So it's going to be the half of the acceleration, then with respect to the time. But in this case, the time will increase because the acceleration is what? Is half itself. So this is what I want to explain about this concept. So this is a partial variation, and you must understand that this particular one has to do with velocity, but the other one does not need. Then sometimes, in some case, you need to join the both of them together. So in such case, they will tell you how the car has started, and they will tell you how the car ends. For example, question like a car accelerates from rest with a velocity of 2 meters per second and an acceleration of 5 meters per second squared, and the time it takes the car to get to the particular distance. So they must tell you everything about the car, both from the starting to what? To the end of the destination. So in that case, you use everything all together. Aside from that, if you're asked to find just the distance traveled by the car, you apply the first one, which is this. Then in other words, if you're asked to calculate the distance traveled when the car is already moving, the car is already in what? In motion. In that case, you are going to apply this. So this is all for this class. So do well to subscribe to this channel. And don't forget to share this video.